Hi all, I'm Poorni, working as an assistant professor in the Department of Industrial Biotechnology, and I'm going to take the topic of MATLAB and Labview in the subject called the Bioprocess Engineering for third year. So before getting into the topic, why we need in the case of a bioprocess industries, why we need to monitor all the parameters. Okay, so here whenever we do a process, the process has to be monitored, and if it has been gone beyond the particular specific level, it has to be controlled by various means. So when we talk about bioprocess monitoring and a control, it is an important and a step to optimize the biological reaction. It has been carried out in the case of a bioreactor for the better optimal production of a product. So here we need to, why we are going for this one, this is one of the most important preliminary step that has to be carried out to get a product in a high sufficient amount. And in the process, it has to be also the more efficient one if you are being carried out in the case of a bioreactor for any type of a biological reaction. And the next one, it has to be carried out in an optimal condition. Optimal condition in the sense, whatever the parameters that we are monitoring and controlling, that has to be monitored in the case of an optimal condition. So it has to be, if the process is to be carried out at a particular temperature, it has to be optimized and it has to be carried out at a particular temperature. That's why we call it as an optimum temperature for a particular reaction or for a particular product. Okay, so here why we are maintaining that. So the same way we can do the optimization in the case of various parameters like your temperature, your pH, your oxygen concentration, and your whatever the things, things that has been needed for preventing the foaming which has been formed while during your reaction which is being carried out in the case of a bioreactor. Why we are going for optimizing all these things in the sense, it has to be optimized for your particular cell growth so that your product will be formed in a case of your stationary phase. Okay, so when we talk about a bioprocess monitoring and controlling, it is one of the most important crucial steps that has to be monitored to be controlled for any better product and a biomass yield to be formed. And it also speaks about a more efficient one, and it has to produce a maximum product formation. So here, when we are seeing about this monitoring and controlling, it cannot be monitored and controlled in a manual way if it is being carried out in a large pilot scale, right? So here we are going for using the computer assisted programming various things for a better bioprocess improvement. So here, what are the various bioprocess? So like we are going to, like how we are going to do it in a manual, in a computer assisted control, in the sense, in a control room we'll be having the program so that can be scheduled so that it can be supervised. That is the computer train, it has to be supervised, and the automatical control that has to be done if the parameter is going beyond the setup value what we have been set it for a particular product to be carried out. Right. So here in this case, why we are going for a computerized bioprocess control in the sense, because it gives you the stability of an operation. And the next one is the reproducibility of a bioprocess, which means that the optimal conditions of a bioprocess has been carried out in the case of a bioreactor for a product to be formed. And it also gives you the product yield in a high efficient way. Then it also helps to regulate your environmental conditions. So the next one, it gives the accurate result as well as in a controlling of a various things. So when we are monitoring this one, what are the various troubleshoots we do have? So here in the case of a troubleshooting, the disadvantage, whenever we are having a set a particular value for this one, like a particular setup, if that value has gone beyond that particular setup value, it will give you this, it can be sensed by the particular device. It gives a indication in the case of a control room by using the software, so that it might Sometimes it might give, sometimes it might not give you the particular signal. So here it can be controlled in the case of a parameters as well as your set points that we have been going to set it for a particular process that is being carried out. So that particular process characteristics that can be changed according to time to the time. So the operational condition also to be changed for it. So based on it. Okay. So whenever and this type of phenomenon, whenever it has been carried out, we call it as said to be the adaptive control system. So here, this adaptive control system that has to be designed based on estimation algorithms and various algorithms with the minimum knowledge that we have to be know about that particular bioprocess process reaction that has been carried out in the case of the reactor, as well as it has to be understand what is the kinetics that is being carried out for a particular product formation. So when we talk about a bioprocess modeling, and here it is used for your understanding the performance of your bioprocess reactions, what is being carried out in the case of the reactor. Okay, so in order to maintain that particular optimal condition. So the simple way we can say it involves a representation of a particular process, how it is being carried out for a optimal product formation by the substrate utilization. So why we are doing for a simulation? So why we are going for a bioprocess simulation? This bioprocess simulation, when you talk about how we are going to carry out this one for getting the optimal product. So how it has to be process, it has to be carried out, that we have to be predict by performing a experiment that can be linked with the help of a computer that can be controlled. So that it can be used for a controlling. So we in a simple term, the simulation can be said as a model or representative example of a process that is being carried out, which involves your various factors also, like your what are the various parameters, like temperature or pH or oxygen level, or if it has been needed your oxygen for a starting of a reaction, and what are the things that has been needed. So it is something which can be stimulates the systems and environment in order to predict the actual behavior of an experiment that can be assisted with the help of a computer. So here, how this and all can be done in the case can be explained with the help of various software tools. And in our syllabus, we do have only the MATLAB, Simulink, and your Labview. So here in our class, we are going to see about a MATLAB. So when we go into the MATLAB, it is said to be the mathematical expression can be used in the case of a laboratory conditions for the product optimization. So this type of your control system can be done using your computer software. Okay, so here when we talk about a computer software, if you are using, it uses your various flow charts we do have. So how the flow of a process that has to be carried out. So what is the first step, what is the second, what is the third, and what is the, so what are the n number of steps that has to be carried out in a flow manner, that we have to work it out when we are going to insist in the case of your incorporate in the case of your computer software. So why we are going to do in the sense, because it is for your understanding the control and the regulatory mechanism that has been generated during your biochemical processes. So as I have told, there are various process or tools that has been used, laboratory tools, computer software tools that has been used in the case of your large scale industries for monitoring the various biochemical process. Okay, so these are the perfect tools that has been used for controlling the process within the bio system. So we'll be seeing about a MATLAB and a Labview. So when you talk about a MATLAB, what do you mean by the MATLAB? The name itself indicates in a large scale or in a laboratory scale, we are going to do this various number of an experiments, so that it can be used for using the matrix form. So as you all know, it is said to be the matrix formation combination of a matrix in the case of a laboratory. So when we talk about a matrix, it is said to be the MATLAB is said to be the mathematical software for a matrix computation. So as we all know, so how it can be written, it can be written as an array with a space or a gap in the case of things that can be used for determining the eigenvalues as well as your eigenvectors for a various tasks. So this can be incorporated in the case of biochemical industries for estimating the optimization of a product formation as well as the kinetics one. So it is for solving the solution of a system with the help of your linear equation. So when we think, so as you all know that the matrix is said to be your array of numbers, right? So here we are going to incorporate those values in an array form, and we are going to optimize the product in the case of a laboratory scale as well as in the case of a large pilot scale. So it is said to be, so we all say that it is MATLAB is said to be the high performance language for a technical computing. So how it can be computed? It can be computation, integrate with the computation, it can be visualization and programming in an easy to use environment. So these are the various things that can be making the MATLAB as a high performance language for utilizing in the case of a bioprocess industries. So what are the uses it includes? So what are the various things? So here the uses includes your matrix one, the computation one, how we are going to compute it, what is the algorithm development, that means your the workflow, how we are going to carry out, then the modeling and the simulation on a data analysis, and how we are going to visualize those things that can be monitored through the computer control room. And what are the graphics, like whether this reaction is being carried out in a first order kinetics or second order kinetics, that can be determined whether, which gives you the optimal product formation by utilizing the maximum substrate of a process. So the next one, it can be used for a application development also, so which includes the graphical user interface building. Then the MATLAB. So here in this case, the MATLAB is said to be the interactive system whose basic data element is an array, that we do not require any dimensioning, which means that whatever the input we are going to give, that input that has to be not changed till the process is being carried out. So it has to be incorporate it with the basic data that has been needed, and what are the various sources we have been given, those data that we have to keep it in a computerized manner. So this allows to solve many technical computer problems with the matrix and a vector formulations using your C language as well as a Fortran as well as a C++. Then what are the various features it has? So when we talk about the features, it has a family of application specific solutions. So which means that it has a various toolboxes. So how we are going to designing, what is the workflow, from which step it is being connected to the what other step, that is the workflow of a step that from carried from a first one to the another, from second to the third, how it is being connected. So that has to be make use in the case of a toolboxes. So that this toolbox is allowed to learn and apply the various technology, which is said to be the collections of various files, so that it can be used to solve various classical problems in the case of your bioprocess. So this toolbox, which includes like signaling, how it has been sensed, like with the help of your sensors, that can be used as a toolbox. Then how it can be controlled. So if your temperature has gone beyond the particular setup point value, the control system in which the thermometer, which has been sensed by the thermometer, that can be controlled with the help. If it has gone beyond that, we have to make a cooling water jacket, right? So that once it has been sensed by the sensors, in the case of a thermometer, then it will be controlled with the help of that water jacket, so that the cool water will be passed through it, so that the process will be carried out in the setup point of a temperature value. Okay, so what are the various networks it has, and how it can be incorporated in the various things, and what are the simulation that can be carried out in the case of application specific solutions called the toolboxes. Okay, to solve the various problems. So here the same way it can be done for your pH, or it can be done for your oxygen if it has been needed, or if it has been carried out in the case of an oxygen, or a foam level if it has been gone beyond, we have to add the antifoam, so that everything that can be controlled or sensed by the signal, and then it's being controlled by the neural networks with the help of a toolbox. So how it has been working environment. So this is said to be the toolbox and the facilities that has to be used using the MATLAB user or a programmer. So once you are going to utilize this MATLAB for your optimal thing, then it the trainer that has to be well trained by using this MATLAB one. Okay, he has to be a well versed in the case of your MATLAB knowledge, so that can be used for managing the variable in the workplace, and also helps to give the data and what are the output data that can be taken off. So it also includes the tools for developing, managing, debugging, and profiling of MAT files. That is why we call it as the M files. And then the handle graphics. So what are the various features it has, we are seeing. So the next one is the handle graphics. So handle graphics in the sense we can visualize, or we can easily estimate what process is being carried out at time to the time, how the reaction is being carried out at a particular temperature, pH, that can be monitored, and it can be done in a graphical manner for a easy estimation of how the reaction is being carried out. So that is why it has a comments like a 2-dimensional or 3-dimensional data visualization, or image processing, or animation, or a presentation graphic, how it has been introduced. So it uses your graphical user interface for on your MATLAB applications. Then whatever the things that has been monitored, that can be stored in the case of a functional library. So if we are monitoring what are the various pH it has, the pH will be varying, like your 1 to the 2. That is, if you are having a set value, like your 6.8, if you have been set point, it might go beyond and it might go below, like your plus or minus. So 6.8, if you have been set up as a set value, it might go beyond the plus or minus of a 1.2. Let us take. So that things that can be used to summation. So the summation, if it can be done at the end of the process, this process can be carried out not only in the case of a 6.8, this process can give you the particular reaction of a product in an optimized one in a particular temperature or a particular pH that can be done. So that summation at the end of the product, how it can be done. So those functions of a mathematical one can be stored in the case of a mathematical functional library. So the functions like your summation, your complex arithmetic for your function that has to be carried out, that can be stored in the case of a MATLAB mathematical functional library. Then the application program interface, that is said to be the API. So this uses, we all know that this library which uses the basic programming language of a C and a Photon. Okay, so that has to be interacted with your MATLAB, so that it will give you the dynamic linking for writing and writing your MAT files. So let us take an example of this one. So when we talk about your reaction, if it is being carried out, so this is said to be the A reactant in which your B product has been formed, and this B product, when it's not said to be the complete product. So we call this as an intermediate, and when the intermediate, this is going to give you the final product as a C form. So what reaction is being carried out, and what are the various process it has been workflow that can be monitored in the case of a MATLAB, so that it can be used or for the conversion for estimating the conversion of a product in this C form. So here we can say we are going to set various CA value. So CA value, so we are going to give the concentration of A. Okay, the concentration of A, the maximum one, we are going to give a 1 glucose. Let us take a 1 substrate as a glucose. Okay, so that we are going to give it as a maximum thing. Okay, so what is the second B value we are going to? So what is the second substrate here? So the next one is a final N value. We do not know what is the value it has been formed. So that has to be kept it as a 0. So what is a K1, K2? That is said to be the rate constant for the reaction 1, which has been formed from A to the B as an intermediate, from B to intermediate to the C as a product, that is the K2. Okay, so here we have to make the, if you see here, it is said to be almost uses the C programming symbols like a void, if, like that. Okay, so here the same way we have to write a program till the process is being over. Okay, so or till it gets finished off. So what are the various if you want a graph, so for the finding the graph in which a time range also, it has to be made it in a things. Okay, so here the time ranges from your 0 to the 15 minutes if you need to monitor, that is the thing. If you monitored at a 24 hours, that has to be given as a here. Okay, so the same way it has to be given, and final graph if you want to do. So what are various plots we need to plot? So that also it has to be given for easy identification of a kinetical paths. Okay, so here this can be explained in the case of a help of here one thing that is said to be, we are going to give the setup point as a 50. Okay, so that 50, when the process is being carried out, that can be elevated, or it can be goes beyond other thing, right? So here it is said to be the plus or minus up to C. So here this can be controlled with the help of a controller that has been incorporated in the case of any bioreactor as a proportion integral derivative controller. Okay, so that will give you the process and give you the sense. So what has to be monitored, formed as a or maintained as an accurate value, that will be the scope for things. Okay, so that can be monitored in the case of your automatical controller using your MATLAB software in the control room. Okay, so here whatever the reactor initial reaction is being carried out. So here in this case, your thermocouple, in the sense, let us take an example of a temperature. So if the temperature has gone beyond, it will be sensed by the sensors that can be controlled with the help of a PID, which has been incorporated inside the reactor or buildup of a reactor. Then if it has been below the value of a setup point, we have to form a hot water to be circulated around the reactor for the reactions to be carried out. So those things that has been incorporated, and this type of workflow that has to be incorporated with the help of the MAT file called a MATLAB. So the next one, we'll move on to the next type called a Labview. So most of the industries, they'll be using the MATLAB and the Labview, and the MATLAB is a simple software that can be done by the trainer. So the trainer that has to be provided with the training facility so that he can be able to monitor the various parameters. So here in this case, if it is of a Labview, when we talk about a MATLAB, it uses your basic C language as well as a Photon. So when we talk about a Labview, it uses a data acquisition system software, so that it uses the high end of a language called a C++, Perl, everything. Okay. So here in this case of a Labview, it uses the data acquisition system, so which converts your analog waveform into the digital value that can be seen in the case of your computer. So that is why we have a term called a data acquisition system software. So it is used to monitor the complete operation of a plant, to maintain an online and a safe operation that can be easy to operate and a self-reliable one. And when it compared to the MATLAB, even though it is in a high end of using this thing, it is said to be the user friendly, because we can visualize your process at any time in the case of your laboratory or a large pilot scale when the process is being carried out. So when you talk about your data acquisition system, there are various softwares that has been used, various components it has. The components are said to be the converters and the sensors. So the sensors is said to be the monitoring the parameters as an input that can be converted into the electrical signal. Then the analog to the digital converters, in which converts your sensor signals to the digital value, so that can be recorded easily in the case of a control room automatically. So here this is said to be your data acquisition system workflow, how it is being carried out. So the physical system, which means that it is able to monitor your temperature or pressure, or what is the flow rate, or what is the oxygen level, or if it has been needed your foam, or if it has been needed your water, the temperature, everything that can be monitored as a physical system. Then it is being transduced to the next level called a transducer. So the transducer, in the sense, this is said to be the electrical signal that can be conditioned with the help of your filter. Okay, so once it has been filtered, this signal that can be converted in from an analog to the digital one, so that it will give you the value in a display in your digital display. Yeah, that is said to be the computer. Here we go. Okay, so here when we talk about a physical system or a condition, it can be used as an input right? So that can be represented in digital form, like your temperature or a pressure or a light or a force or displacement. The transducer, it converts your physical condition, whatever the input we are giving, that will be converted into the waveform for a EC signal processing. So then this, whatever the waveform that has been transduced, that will be conditioned with the help of a signal conditioner. So that will be converted into the digital processing using this software. Then this analog to the digital converter, whatever the signals that has been formed in the case of a digital form that has been formed from your electrical wave by your transducers, those digital process will be converted into the digital display to get the final value. So this combination of this various parameters, various components, we call it as a data acquisition system. So here we need to monitor what is for your data acquisition system. You need to work the DAS hardware, which uses a high-end language like a Visual C++ as well as a C++ and a Pascal. So when you talk about a Labview, it is said to be the Visual Instrument Engineering Workbench, BIEW, Visual Instrument Engineering Workbench, that has been utilized in a laboratory scale for the product formation in an optimized by utilizing the substrate one. So in a simple language, it is said to be the graphical programming language that uses the icons instead of lines to create the programs. So what are the other names we can say? The other names is called said to be the visual instrument. Why we call it as an instrument thing is said to be your, it maintains your block diagram, which helps to monitor the each and every parameter that has to be monitored in the case of a physical factors. Okay, so like a temperature that we have been seeing in the DAS system software, right? So here it is said to be in a simple term, we can say it is a graphical programming language that uses the icons instead of lines to create the programs. So when we talk about the same way, what are the things we have been seeing in the case of a MATLAB, we are going to see in the case of a lab. So what are the features when we are designing? What are the processing that we need for a signaling or for a image processing that has to be designed in such a way? Then what are how this designing that can be incorporated in the PC, that is your computer or a microcontroller? Then how it can be simulated? So that can be used your Simulink software for your optimization. Then the control, so how it can be controlled in a dynamic system that can be done, whether we are going to control it in an automatic way or it can be done in a robotic way. So in a large scale industries like your car manufacturing industry, if you see, they'll be using a robotic various equipments for the controlling system. So here in the bioprocess, we'll be using your not a robotic, we'll be using only the automatic control for your system. Then what are the various measurements? It needs your circuit connections and electronics and measurements, how it can be done. So when we talk about a Labview convention, what are the various three parts it has? So here when you talk about your three parts, it has your front panel. That is what we are going to give it as an input. Okay, so that can be interacted with the users and displays the control as well as your indicators. So the like your caption and a label. So what are the things that we are going to give? So what are the various symbols? If it is of a pump, what symbol it has to be used and how it can be opened up when it has to be opened up. So that is said to be the front panel. Then the block diagram, this block diagram, it will be consisting of a code. So whatever the symbols we have been used in the case of a front panel, that has to be coded as the code that will be invisible for our monitoring one. So that is said to be the block diagram. Then the connector panel, which means that what is the connectivity which is present in the case of a Labview, which connects your front panel and a block diagram. So which means that it means of passing the data from one to the another one. So in order to display whatever the values in a digital form. So this is said to be the three tools which has a various connectivity. That is said to be the first is the control palette, then tool palette, then the functional palette. So the control palette is said to be your what are the various physical things that we need to monitor. So if it has to be on, it will be on automatically. If it has gone beyond the temperature what we have been said, if it will be on, so that if it has been needed, it will be your cooling water will be circulated around the reactor so that the temperature will be maintained. Okay, so the same way, so what is the tool? So here how we need a tool, so like your hand signal or your arrow signal, if we did, that can be picked up with the help of these tools. Then the function tool, so how here, so the function tools in the sense, if the temperature is gone beyond a particular level of a set point, it has to be circulated around your cooling jacket, so that how long the water has to be, cooling water has to be circulated around the reactor to maintain, to bring out the temperature, to bring down the temperature. So those function palettes that has been designed here. Okay, so when you talk about this function palette, they're the same thing. So it is said to be the functions which will be grouped into the category, so that what are the various function that parameters that is being monitored in the case of a physical one. Then how it can be controlled. So this can be controlled in the case of your control front panel, with the help of a front panel, that controls can be grouped into the category. Then the tool palettes. So what are the tool palettes it has to be needed? So whether it has been needed in a separate toolbox corner of a top, which were wiring or a probes or a coloring that can be done. So these menus that can be used with the help of a pull down menu. So whether if the process is being carried out, whether it needs a control or an indicator. So whenever we need this one, this one, so the control is said to be whatever the input we are going to give from the user side. So we call that as a source terminals. Okay, so when we talk about the indicators, it is said to be the digital value what it has been given for us to be recorded in a automatical control room. Okay, so that is said to be the output to the users. Okay, so whatever the inputs we are giving from the user side, that is when we are giving the source, that is said to be the control, and the indicator is said to be at the final end destination, what is the output we do have. So here, these are the various wires that are being used in the case of a Labview for a digital control as well as an indicator. So this we do not. So this delivers your data from one terminal to the another terminal. Okay, so if it has been, if we are using the wiring systems, what are the various wiring systems if we have been used, that can be indicated in a various colors and a various forms, like as a net lines. Okay, so same way, so this can be given with the help of example of a thermometer temperature. So if we are going to find a temperature, so we are going to set a degree, that has to be converted into the Fahrenheit, and how this Fahrenheit that can be converted, that has to be programmed, and those formula has to be fixed in this panel. Okay, so that is said to be this control panel. So it's said to be the Labview software, where we are going to incorporate all the formulas for your this one. So at the final one, it will give you the value in a, if we have been set it in a degree centigrade, it will give. If we have been set it in a Fahrenheit, it will give in a Fahrenheit form. Okay, so if we want it in a degree centigrade, that is said to be the control one. We have it given. So the indicator is in the sense the input what it has been, sorry, the output what it has been given for the users, which has been taken from the controllers, that is said to be the indicator. So that is, if we need it in a Fahrenheit, it will give you the value of a Fahrenheit. For this conversion of formula, that has to incorporate in the case of your Labview model. Okay, so that is in a front panel, the block diagram, the connectivity we do have seen in the case of a three main parts of a Labview. No? So in that, it has to be incorporated so that it will convert the degree centigrade into the Fahrenheit. So this is said to be the block diagram, as we all know. Okay, so from this, it will take up the things, and in this Labview software, if we have been incorporating this formula, it will tell you the value as in the form of an indicator bar. So the Labview is written on a graphical structure. It is said to be the summation and can be represented as a various symbols also. So it uses both your logical form as well as the mathematical form. When you talk about a MATLAB, it uses only the mathematical expression for your laboratory estimation of parameters. Okay, so here in this case of a Labview, your logical function of a various gates can be used for, as well as with a combination of a mathematical one. So here in most of the industries, they are using the Labview software because it uses the higher end languages which can be programmed in a precise steps itself. Rather than writing in a n number of steps for programming, we can write a number precise steps for things for your estimation. Okay, so here in this case, what are the various? So here in a graphical, in a flowchart, it can represent the starting of your input. That is the controller one. Okay, so the systems to be initialized, it gives you the signal how it has to be converted in the case of a data acquisition system unit. Then what are the various parameters that has to be monitored that can be stored in an array? That is the mathematical form. If we do need that, can if your process has been over, then it will be giving you the plot. That means your output in the form of an indicator. Okay, so that can be used to calculate the efficiency and various factors that can be done. So then we will be stopping. If not, it has to be written back to the particular process so that the whole process, till the process being carried out, then we have to carry out the steps. Once the process has been winded up after 24 hours or 48 hours or 72 hours, this process can be stopped. So what are the various advantages in the case of a Labview? It is ability to solve and execute the complex algorithm in a real time because it uses your mathematical as well as the logical systems, and easy to learn, use, maintain, and upgrade. And it has to be used your new application program interface, right? That is an application program interface API that has to be facilitated to improve the data security, and it also helps to make the data to be integrated and saved in the case of an automatical controller system in the automatic control room. So the disadvantage when you talk about this is said to be a complex program that has to be trained in a the trainer should be efficiently trained so that before using the Labview software for any startupping of a processes. Okay, so the damage to the database also occurs, and those database systems are very complex and difficult to design, and it's said to be the time consuming one. So here, what are the various applications? Well, what are the various fields we are using the Labview in the case? It can be used in the case of various electronics and electrical communication industries. They are instrumentation industries, your process control, like a bioprocess or a chemical process, or in a biomedical equipments, and it also involves in the case of a robotic. So when we talk about a MATLAB, this will not be used in the case of a robotic one. The automatic one, it can be done, but the robotic way it cannot be done. So in the case of a Labview, it can be done automatically, as well as your robotic system can also be used for that. Okay, so here then the image processing. So here when we talk about how the reaction is being carried out, so what are the various whether the reaction is being carried out in an efficient way, that can be monitored in the case of a Labview software that has been run in the case of a automatic control group. So this Labview can also be used in a various research field.